Hello, I'm Shivan Mishra. So today we are going to discuss a problem that is 289 game of life. So as you can see here, we are given a board which has a initial state where each element is going to be 0 or 1. 0 is going for the dead and 1 is going to for the live. That is means it is living, it is alive, and each cell is going to interact with its eight neighbor, eight neighbors. Eight neighbors mean let us take that cell and it is going to them, 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 and them. Okay, understood? Yeah. So these and we have the four rules using which we are going to we are which using which we are going to give the next stage, which are going to be this next, which is going to be the next stage after that particular stage. So here are the four rules, where three rules are for the alive cells, which cells are living, and one for the dead cell. So for a living cell, what are the rules? As you can see here, two living neighbors. If any cell, any living cell has two living neighbors, then it is going to die due to underpopulation. And if it has two or three living neighbors, then it is going to be alive. But if it has more than three neighbors, and it is going to die due to overpopulation. Maybe there are some reason that is going to starve of the food. There is a scarcity of the food, maybe something. So, okay. And the fourth rule is any dead cell which is exactly three living neighbors. Any dead cell which has three living neighbors is going to die. Sorry. Which is going to be alive again due to reproduction. Okay. So the next state is going to be determined by applying these four rules, okay, and simultaneously, okay. So these rules are going to simultaneously apply. That we have that a particular state, and it is going to just apply. It is not going to be in a way like that. One state, then other, then other, then other. We are going to move whole grid. It is going to be applied as a whole at once. Okay. So we have to give the next state and we have to update that particular code. We are not going to change it or not. We are going to return anything. We are going to change that particular code. Okay. So let's take it. Yeah. Let's go to the escalator. Let me paste it here. Yes. Yes. It's so here, as you can see, for that particular, mm, yeah, as you can see for that, it is what are the neighbors? It has these. So for that, the count of living neighbors around it are is one. So it is okay. Let me um, get the rules for the living. Sorry, just give me some time. Here. Yeah. So it has how many living neighbors? Only one. So what are the rules for the living? As you can see, it's dead, and dead rule exactly three living neighbors. We need exactly three living neighbors, but it didn't have, so it will be dead. For the one, it has how many living neighbors? One. It will be. It is going to die. Why? For the livings, we need Wow, how many, if it wants to be alive, then what it needs? Two or three living neighbors. Here, only one living neighbor, so it's going to die. As you can see here, it's died. And for this, one, two, two neighbors, two living neighbors, two, but it's not alive, it's dead. And for the dead to become alive again, we need three living neighbors. Okay, so it's also not going to be reborn. For here, we have one, two, three. It's dead, and we have three living neighbors. Then, as per this rule, it's going to be alive again. It's going to reincarnate it. So it's alive again. For that, one, two, three, four, five. Okay. For that, one, two, three, four, five. It should be alive. Why it's not alive? Mm, mm, Wait a second. It's dead. Oh, what is the rule for the dead ones? Three, exactly three living neighbors. But here, one, two, three, four, five. For that particular element, for that particular dead cell, we have five living neighbors. As we know, if living neighbors are greater than three, the living cell is also going to die because of the scarcity of the food. So it's also zero. Yeah. For that one, two, three. Yeah. Three. Living, two or three, as per the rule two. If we have two or three living neighbors, then it's going to, if it's alive, it's going to alive. For that, one. Only one living. So it's going to die as per the rule, first rule. Okay, for it, one, two, three. It's going to be alive as per the rule two. Okay, for that, one, two. Okay, it's going to alive as per the rule one. Okay, for that, one, two. For the dead cell, we need exactly three living, no neighbors. But we got only two, so it's going to be dead. For that, we got three living neighbors. Yeah, we got. So it's going to be alive. It's going to be reborn. For that, one, two, only two. So it's going to be dead. So I think you have understood it pretty much. So let's get down into the coding part. Okay. So first of all, okay, what is about size? We are going to get the code size now. We are going to create it. Okay. So we are going to create. Okay. Now we need to count the neighbors also. What is the count of living neighbors? Neighbors. Uh, let's- yeah. Okay. So the living neighbors are initial zero. For each cell, we are going to set the living neighbors to zero. Now we need to traverse for its neighbors for that cell. Okay. Okay. For, okay. So I think you are able to understand what I'm doing here. So and that too, with these loops, we are going to iterate the whole grid, and we just set the living neighbor for that particular cell zero. Now we are going to traverse its all the neighbors, all 8 neighbors. So x is equals to I plus k and y is equals to j plus l. So these are going to be the indexes of k, k, k equals to 0 and equals to 0 and continue. Why? Why? Because it is the same cell, I comma j. We need what? We don't want to count its if it's alive or dead. We are not going to count that cell. We only need the neighbors. So for the neighbors, okay, if x y is equals to then L neighbors, okay, if it's alive, then increase the count. Now if living neighbors are less than 2 or neighbors are greater than 3, then board X, no, board I j is going to 10. Here we are not going to use any extra space, so we are marking it as -1 as it was alive before. Okay, so let's check for if it's alive or dead. Then we are going to use these rules. If I j, if it's alive, then that rule as if within neighbor is equal to 3, then I and j is going to 2. Why? Because it's initially dead, we make it alive. We make it that it is like reward. And here, if board x y is equals to -1, that means it was alive, but it's now dead. But as for our calculation for the living neighbors, we need to count it because that process is going to be the simultaneous. So we need to count it. Okay. Now it's again I think yeah. So now we just need to traverse it again, and if there is a -1, then we are going to replace it with 0, and if it is 2, then we are going to make it 1, as we need 0 for the dead and 1 for the living. Yeah. Yeah, almost done. Now, if board ij equals to -1, board ij equals to 0. So I think it's almost done. So what we have did here, we traverse for the grid for each element, for each cell. We are going to set living neighbors 0 And now here to traverse all the 8 neighbors, we have did that so that that particular cell is not going to counted as its neighbor. So if its neighbor is alive, or if it's being alive but now it's not alive. Okay, understood? It's now not alive, but it was alive in the past. So we are going to count it. Okay. So now if then that particular cell is living, then it's needs to, if neighbor is if the living neighbors are less than two, it's going to die due to the underpopulation. If they are greater than two, if these are greater than three, then it's going to die with the overpopulation. And if it's already dead and living neighbors are three, then it's going to be reward. Okay. So now just if it's now it's dead, then we are going to make it 0. If it's now alive, it's going to be 1. Now let's run it. Runtime. Runtime. How it can be. Oh, okay, okay. Just yeah, we have to check that. Yes, sorry, my mistake. If as you can see, for if let me go for that. Yeah, here. I mean, if we are going for that particular, then these are the neighbors, but as per our the for loop, it's going to get the all 8 neighbors. That means, yeah, that also, but that line is not there, that part is not there, so it is going to give us overflow. So for that we have to write here if same way for the y. Yeah, I think now it should be correct. Yeah, as you can see here, test cases are pretty much done. Now for the, yeah, it's submitted with a 100% beat, as you can see here. So for the time complexity, okay, let's go here to the complexity part. And let's screenshot of it, paste it here. It will be much better. Yes, yes. So for them, it's going to be the n square. So n, sorry, n. So what is going to be complexity? Due to that, it's going to n. Due to that, it's going to be n. Now we are traversing it 3 cross 3, 3 times, 3 times, yes, 3 cross 3, yeah, and no, 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 no. So the time complexity, time complexity is big O of n star n. You can say that if you want exact time complexity, 3 plus 3. You can say that. And for the space complexity, we didn't use any extra space, so it's going to be the figure of 1 as we use the given matrix. So you can say that n cross m or whatever, but we did not use any extra space. So you can say that it's constant, pretty much constant. Yeah. So that's all from my side for the time being. If you have any doubt, you can comment it. And if you have any suggestions, then feel free to give it, as it is my first video. So, okay, thank you.